Okay, in this video we're going to be talking about polynomial long division, but we're also going to be looking at synthetic division and the polynomial remainder theorem. So before we long divide polynomials, we need to take a step back and think about long dividing two numbers, like we did in 4th or 5th grade or whenever that is. And so I'm going to ask about what is 47,565 divided by 7? And so when we do it, we set it up like this. And this is the same as, 47,565 divided by 7, or maybe written like this, 47,565 divided by 7. Okay, so for all of these, the dividend is the thing you're dividing up. Okay. The divisor is the thing you're dividing by. Oh, whoops. Forgot we had 3 representations. And the quotient is what you're going to get back after you divide. It's the answer, so to speak. So the first thing you're going to do is you're going to take the 7 and you're going to say, well, how many times does 7 go into 4? Well, it doesn't go into 4, so you kind of look for the next layer. How many times does 7 go into 47? Well, 7 times 7 is 49. So you go with the next one down. Okay, so that's going to be, it goes in 6 times. So 7 times 6 is going to be 42. And then what we do is we take the 6 and we multiply it by the 7. That's 42. We subtract 42 from 47. We get 5. Drop down the 5. And then kind of, move the target down. You think, how many times does 7 go into 55? Well, 7 goes into 55. 7 times 8 is 56, so we have to go with 7 times 7. You have to go with the next one below. And you take 7 times 7, and that's 49, and so we're going to subtract 49. And that's equal to 6. Drop down this 6. You think, how many times does 7 go into 66? And 7 times 9 is 63, so that's seeming like a pretty attractive option. 9 times 7, 63. Subtract the 63, and you get 3. You bring down the 5. And then what do you know? 7 goes into 35 evenly, and so you can say 7 times 5 is 35. And okay, there's nothing to be gone in, and you're done, right? That's when we know we're done. So what we could say is that 47,565 is equal to 7 times 6,795. And then, but that's not really what we're asking. We're talking about division by 7, right? So I'm going to divide both sides by 7 and say 47,565 divided by 7 is equal to 6,795. And you'll see in a minute why I wrote it like I did up above. Here we've got another one, and this one I'm more interested in what happens to the end, so I'm going to kind of quickly go through the same steps. Okay, 6 times, you're thinking, well, how many times does 6 go into 18? That's 3 times. Okay, so you have subtract 18, and that's 0, bring down the 4. Okay, well, this is something interesting. Well, do y'all know, what do I do when I say, how many times does 6 go into 4? What do I put there? 0, yeah, because it's too small. Okay, 6 times 1 is 6, and we go with the next one below that. Okay, so that's 0. Okay, so 0 times 6 is 0, and we subtract that, and we get 4. You bring down the 5. Okay, now you're thinking to yourself, how many times does 6 go into 45? Well, 6 times 8 is 4. 6 times 7 is 42. That's right up underneath it. Okay, so 6 times 7 is 42. Subtract that, and I get 3. Bring this down, I got 33. Thinking, how many times does 6 go into 33? That'll be 5 times. Okay, and then I've got 6 times 5 is 30. And then I've got 3. Okay, and I've gone to the end. And we could go into decimals, but we're not big decimal people in this class. So what do we call this 3 back in the day? Call it the remainder, yeah. And so maybe you wrote it with an R3, or maybe you did something a little better. But what I'm going to say is that when you divide 18,453 by 6, you get 3,075, but with 3 kind of left over somehow. So what it is 18,453 is equal to 6 times 3,075, but with 3 left over. Okay, so this is why we do the certain thing that we do with the remainder. Okay, so what I do is I'm dividing by 6. So I divide everything by 6. Divide both sides of the equation by 6, or distribute a 1/6, however you look at it. Okay. So what you do is that you say 18,453 divided by 6, which is what we were interested in. Okay, and this is like last time, we canceled the like factors. 3,075 plus 3 over 6. And that's why over here, you know, what you might have done in elementary or whenever you long divide numbers is you take this remainder here and you put it over the divisor. So it's going to be 3 over 6. Maybe you even reduce that and made it 1/2, but it doesn't matter, right? Same number. Right, now I think we're ready to divide some polynomials. Okay, and this is kind of a, you know, the easy case, get you started. And for the most part, the ones that we're going to divide today, on the homework tonight, on the quiz next time, are going to have a remainder. Because if they don't have a remainder, then it must be the case that your dividend is factorable, and you can factor and cancel the way that we did last time. And so, since, you know, we're trying to move forward, trying to do new stuff, we're going to be looking at ones that mostly have a remainder. So, what I'm going to do is I'm going to say I've got this divisor of 2x, and what do I multiply 2x by to get 20x squared? Well, you know, you can take it one step at a time. Maybe the numbers. 2 times what is 20? 2 times 10 is 20. And then x times what is x squared? X times x is x squared. And then just like we did before, you take the 10x and you multiply it by the 2x, and you get 20x squared. And then we subtract, and you get 0. And you bring down the negative 4x. And then you kind of move the target, saying, what do I multiply 2x by to get to negative 4x? You would multiply that by a negative 2. And you take the negative 2 and you multiply it by the 2x, and you get a negative 4x. And you subtract the negative 4x. It's like I subtracted 20x squared, or I subtracted the numbers up above. And negative 4x minus negative 4x is like adding 4x is 0. Okay, so I have a remainder of 0. In general, though, it's not going to work out like this. There's going to be a remainder. Okay, here we've got one that is certainly going to have a remainder because x squared plus 7x plus 13 doesn't have x plus 3 as a factor. I can't think of some integer that I could multiply by 3 and get 13. So it's not going to factor nicely. It's not going to cancel or anything. So, and in this case, when you have multiple terms in the divisor, you're just looking at the first thing. So you're thinking, what do I multiply x by to get x squared? And then you let that dictate where you go from there. So you multiply x by x to get x squared. And then you take x and you multiply it by x plus 3. Okay, so that's x squared plus 3x. And, okay, you write that down over here, x squared plus 3x. Then we subtract this. X squared minus x squared is nothing. 7x minus 3x is 4x. We drop down the plus 13. And then you say, what do I multiply x by to get 4x? You multiply x by positive 4. Okay, so then I'm going to do the same thing. I'll have 4 times x plus 3. And that'll be 4x and plus 12. So I've got that here, 4x plus 12. Okay, we're subtracting that, and that's 4x minus 4x is nothing. 13 minus 12 is 1. Okay, x plus 3 doesn't go into 1. It's like the wrong degree, so I'm gone as far as I can go. The remainder is going to be 1. And so I can say this is x plus 4 plus 1 over x plus 3. And, this is my quotient. Okay, this one's going to be a little different because it has 3 terms in the divisor, and moreover, it's got a kind of a missing term in the dividend, right? We go x to the 4 straight to x squared, and the thing that I'll kind of compare this to is, what if you had like 105 divided by 5? Right, if you just had a 1 in the 5 because the 0 was nothing and you just didn't put it there and you had 5, you might not remember to put in a 0, or you might not remember that there is an implicit 0 there, and then you would say that was 3, but we know that 105 divided by 5 is not 3, it's 21, I think. So this is why we need to rewrite this just to keep our place value straight. So that's going to be, I didn't leave myself enough room. I'm going to put the divisor first. X squared minus x plus 1. X to the 4, add 0x to the 3rd, 2x squared, negative x, and positive 5. With the key thing here being the plus 0x to the 3rd. All right, zoom out a bit. Yeah, there we go. Get some room to write above this. Okay. So again, we know that the idea is you take this first thing in the divisor and you say, okay, what do I multiply x squared by to get x to the 4th? That's going to be x squared. All right, yeah, I'm still in the window. So I take x squared and I distribute it into x squared minus x plus 1. So we do this. X to the 2 times x to the 2 is x to the 4. X to the 2 times negative x is negative x to the 3rd. And then x to the 2 times 1 is positive x to the 2. So I'll put that down. Got and then I subtract. And you want to just take it one at a time. So x to the 4 minus x to the 4 is 0, or nothing. If you have 0x to the 3rds and you subtract negative x to the 3rds, it's like 0 minus negative 1. So we're really adding an x to the 3rd. So we end up with positive 1x to the 3rd. 2x squared minus x squared is just going to be 1x squared. And then I bring down the negative x. Okay. Now, I'm thinking, what do I multiply x squared by to get x to the 3rd? That's going to be x. And so then I multiply in this x. All right, so let's see what. Oh, okay, I'm copying down. I lost my train of thought. So x to the 3rd minus x squared plus x, and we're going to subtract this again. X to the 3rd minus x to the 3rd is nothing. X squared minus negative x squared is like x squared plus an x squared is going to be positive 2x squared. And then when I take negative x and I subtract another x, that's negative 2x. Drop down the 5. And then we think to ourselves one more time, what would I multiply x squared by to get 2x squared? You would multiply it by 2. You take the 2 and you distribute it in, so it's 2 times x squared minus x plus 1 is 2x squared, negative 2x, and positive 2. Okay, so I'm subtracting this, and 2x squared minus 2x squared is nothing. Negative 2x minus negative 2x is, well, something minus itself is always 0, and 5 minus 2 is 3. All right, so, and x squared minus x plus 1 certainly doesn't go into 3, so that's going to be the remainder. And then one more time, just to remind y'all of why we put the remainder over the divisor. Okay, I'm going to express this as x to the 4 plus 2x squared minus x plus 5 is equal to x squared minus x plus 1. I don't know where that 1 went, but multiplied by x squared plus x plus 2, and then add 3. And then I'm going to divide both sides by x squared minus x plus 1, because that's what we were talking about. And the same thing over here, because we've got to divide everything. Okay, so we got a little bit of that, and this is equal to x squared plus x plus 2 plus 3 over x squared minus x plus 1. Okay, and you might remember from your Algebra 2 course, or pre-calculus, or who knows, some math class along the way, about this better way to divide polynomials. Okay, and it's much better than long division. And it's synthetic division. Now, the thing is that in this course, we're only going to use synthetic division when the divisor looks like this, just x plus a number, x minus a number. If it's 2x plus 1 or x squared plus 5x, we're not going to use synthetic division for that. I'm not going to say you can't, but it's more complicated than it's worth. Okay, and I'm afraid that y'all would forget the last step, which is just yet another thing to memorize, and we don't like that. Okay, just learn how to do the problems and attack them as they are. Okay, but this one is prime for synthetic division. So when we have x to the third, that's like 1x to the third. And negative 4x squared, 2x, and positive 51. And what we do when we set up for synthetic division is we copy the leading coefficient, or the coefficients of each term. So I have 1, negative 4, positive 2, and positive 51. You copy those numbers down, and then you make a little box, or I think y'all do it kind of different. I don't remember. I remember people telling me that I set up my synthetic division wrong, and that's a funny thing. But the question for y'all is, what number do I put in the box? Do y'all remember? Negative 2, positive 2. It's one of those. It's whatever. What you're thinking is, the number you put in the box is whatever makes that equal to 0. Okay. So in this case, that would be 2. Or you remember it's the opposite sign or something. But it's definitely related to that. So it's positive 2. And you drop it down, and you start with that. And I am presuming that y'all have done this before. You drop down the first number. Then you multiply these two. You multiply 1 times 2. And you get 2. Okay. You add down, negative 4 plus 2 is negative 2. Then you do the same thing, multiply, add, multiply, add, multiply, add. Okay, so negative 2 times 2, negative 4. Negative 4 plus 2, negative 2 again. Negative 2 times 2 is negative 4. You add down, that is 47. Once you reach the end, that's your remainder. Okay. And then the really nice thing about synthetic, there's a few nice things about it, is that these numbers down here are going to be the coefficients of the quotient. Okay, so that means that 47 is the remainder, and I recommend starting with the remainder and going right to left, because sometimes a common error is to kind of be off in your place value, to say x to the third divided by x minus 2 or whatever, it's going to start with x to the third or whatever because there's 4 terms. So start with the remainder. 47 over x minus 2, because we know the remainder goes over the divisor. And then go to the right. The next thing before the remainder is going to be the constant term. Then the x term. So then there's x, and there will be negative 2x's. Then there will be an x squared, and there will be just one of them. Okay? And so that can keep you from making a place value error. That's my recommendation. And that's how we synthetically divide. So these 2 examples here, these are not ones that we're going to be able to use synthetic division for in this course. Okay, if you want to look up how to use synthetic division for less obvious divisors, then you go ahead. But I'm not going to do that in this video. Specifically because I've got this x squared, or x squared and negative 3x. And you just need x plus a number or x minus a number. And here we have another one that is definitely prime for synthetic division because I have x plus a number. No 2x, no x squared, nothing like that. The thing is, again, this has got a missing term. There's no x squared term there. So what I'm going to do is I'm going to set up for synthetic division, but I'm going to remember to put a 0 for x squared, just like I put a 0 x to the third, I think, or maybe a 0x squared, something in that long division example I did earlier. So this is 2, 0, negative 5, negative 6. And then in here, I put, remember, it's whatever causes this to be 0. Okay, so it's going to be x equals negative 3. Okay, you drop down the 2. Multiply 2 times negative 3. You add. You multiply. 18 minus 5 is 13. 13 times negative 3 is negative 39, and 6 is negative 45. So the quotient, start with the remainder term, is negative 45 over x plus 3. You got 13. And then you've got negative 6x. And you've got 2x squared. And that's going to be the quotient. Synthetic division, really ideal. We like synthetic division. And if you feel like you need more practice on synthetic division, you should pause the video right now and you should just do these couple of them. All right, there you go. There are the answers. Okay, and at the end of this video, I'll also put up a few more examples that would be good to do long division on if you needed more practice. Now I'm going to talk about the polynomial remainder theorem. And this is something that it's going to, first of all, help us evaluate polynomials much easier. And then also there is a question that, well, we keep seeing it come up on all of the Clep materials. Okay, all of the study guides, practice tests, they all have the same type of question on it. It's kind of backwards question about the polynomial remainder theorem. And so we want to just make sure to make y'all aware of that and prepare you for that in case you're thinking about taking that test. So if f of x is x to the 5, 3x to the 4, negative 2x to the 3, negative 5x squared, 3x, and 7, how would we find f of 3? What do I do? Yeah, plug in 3 for x. And then you're probably going to want to use a calculator. So I'm going to say that f of, I'm still in pink. Black. F of 3 is going to be 3 to the 5th plus 3 times 3 to the 4 minus 2 times 3 to the 3rd minus 5 times 3 to the 2 plus 3 times 3 plus 7. And, I'll just save you the time of punching that in the calculator, and I'll tell you that that's 403. But you can think that, well, even if I was going to put that into the calculator, that's a lot of button pushing. And if I was going to do that by hand, that would be really annoying. What if there was a better way? So the actual theorem is that if f of x is a polynomial and it's divided by x minus a, then the remainder is going to be given by f of a. Which is to say, the remainder from synthetic division is the same as f of a, where a is the number that we put in that box that we started with. Okay, so I'm going to do this the easier way. Okay, I'm going to find f of 3 if f of x is x to the 5, 3x to the 4, negative 2x to the 3, negative 5x squared, 3x and 7, just like we did before. We're expecting this to come back 403. So I'm going to set up for synthetic, some people might call this like synthetic substitution. And I'm going to put in 3. Okay. So you drop this down. 1 times 3 is 3. You add them, multiply, add, multiply. Okay, 16 times 3 is 48. 48 minus 5 is 43. You multiply 43 by 3, and that's going to be 120 and 9. So that's 129. Okay, you add again, and that's 132. And then 132 times 3 is going to be 396, so 396. And you add those together, and you get 403. So you can say that f of 3 is equal to 403. And that's much easier. Okay, and it's even better when the numbers don't kind of like run out of control like these did. And before we jump into that Clep test question, let's just make sure that you know how to do synthetic substitution right. So I'm going to freeze the screen for you all, and if you're watching at home, you should pause the video because the answer is just going to come up in a few seconds. Okay, here you go. So you run it through synthetic and you get negative 64, right? And when we're doing synthetic substitution, you take this number here and you go direct into the box. Because this is like dividing by x plus 4. That's the equivalent. And so you run it through and you get negative 64. And you can check this using a calculator if you like. And you say f of negative 4 is negative 64. Which is still, I think, easier than keeping track of negative 4 to the third, doubling it, negative 4 squared, tripling it, and doing all of that. It's a really nice algorithm. And here we have kind of the Clep test question. Okay, I took the Clep test for college algebra last spring just to see what was on it. And I got a question like this. We've seen it on review materials and practice tests, and including the official thing that the College Board put out. So, safe to say, they really like this question. And for good reason, it's a really good question. It's a pretty nice way of testing knowledge of the polynomial remainder theorem. So if f of x is x to the 21 minus 5x plus 6, what's the remainder when f is divided by x minus 1? So when I first saw this question, I was thinking, all right, I'll just divide it and find out what the remainder is. And then I went to go set up for synthetic division. I was like, oh, ooh. X to 21, yeah, exactly. But that's the whole point of the question, right? Is that you're not going to put in 19 zeros between x to 21 and x to the first. So what you have to remember is what I had written above. The remainder from synthetic division is the same as f of a. So in this case, f of 1 is going to be the same as the remainder when f is divided by x minus 1. So this is backwards. We say instead of using synthetic, I'm going to just plug in, okay, so f of 1 is equal to 1 to the 21st minus 5 times 1 plus 6. Okay, so I've got 7 minus 5 is equal to 2. So the remainder is 2. Okay, the other thing, what if I asked when it was divided by x plus 1? Okay, so if I change this question, We got another one. It's pretty much the same question, but I decided to switch up the numbers a little bit. And so I said, what happens when, what's the remainder when you divide x to the 21 minus 5x squared plus 6 by x plus 1? Okay, so again, the remainder is going to be given by f of negative 1, because we're dividing by x plus 1. And so that's going to be negative 1 to the 21st power minus 5 times negative 1 squared plus 6. And negative 1 to the 21st is negative 1. Minus 5 times negative 1 squared is going to be minus 5 plus 6. Okay, so the remainder is 0, so it would stand to reason that it divides cleanly. Another question we can ask is x plus 2 a factor of x to the third minus 5x minus 2? And, of course, come with the instructions like, show the analysis that leads to your determination. And so what we're going to do is we're going to plug it into synthetic substitution, right? Okay, so we're going to set up, x to the third. There's no x squared, so I remember to put a 0 there. We've got a negative 5, got a negative 2. And then I'm going to plug in negative 2, drop it down, and then I'm going to run it through synthetic substitution, and I get a remainder of 0. So if there's a remainder of 0, that indicates that it's going to divide cleanly, that x to the third minus 5x minus 2 divided by x plus 2 has no remainder, and therefore it's going to be a factor, because you can write it as x to the third minus 5x minus 2 equals x plus 2 multiplied by, and then we're going to read the coefficients off of the bottom to get the quotient, x squared minus 2x minus 1. So yes, x plus 2 is a factor. You could also say x plus 2 divides x to the third minus 5x minus 2. Okay, I've switched the numbers a little bit and asked, is x minus 4 a factor of x squared minus 5x minus 2? Well, hopefully you can see that definitely it is not a factor, because x squared minus 5x minus 2 is already not factorable, so it's not going to work, and so we should definitely be getting no back. So I'm going to just do the same thing, 1x squared, negative 5x, and negative 2. I'll run 4 through synthetic substitution. 1, multiply, add, add. And we see that since the remainder is not 0, it is not a factor. All right, the last one I've got for you is kind of a backwards version of that Clep question I was talking about. So when x squared plus 4x plus 10 is divided by x minus k, the remainder is 6. What is the value of k? So remember, again, the remainder after synthetic division is the same as f of a, whatever number you're putting into synthetic division. So in this case, if we were going to use synthetic division, we'd plug in k. So that means that f of k equals 6, or the value of the polynomial at x equals k is 6. So I'm going to plug in k for x. I'm going to say k squared 4k plus 10 is 6. I'm going to subtract 6. I've got k squared 4k plus 4 equals 0. Then you can factor this. This is k plus 2 times k plus 2. And so this is equal to 0 only when k is equal to negative 2. So that would be how we would do a problem like that. But that's really on kind of the fringe of what you might be expected to do.